Okay, after you've done the critical path method, which will generate an earliest start, earliest finish, latest start, and latest finish for any activity, you can use that to calculate the critical path, which is a function of slack. Then you can also use that to calculate the probability of meeting a due date. So this is a problem where we have activities. We've already done the activity on Node and built the network. More importantly, we've already calculated the earliest start, earliest finish, latest start, latest finish. With that, I don't need any of this anymore. But I need to use this data to calculate my slack. And the slack is equal to the latest finish minus the earliest finish. Or it could be the latest start minus the earliest start. Or it could be the latest start minus. It doesn't make any difference. You're going to get the same number. And if these numbers are 0, which I'm going to use conditional formatting to show that. That's on the critical path. So our critical path runs through B, C, E, F, H, J, K. That's our critical path. Well, the next step is to calculate the probability. If I have a due date, let's say, and my project is going to finish when? It's going to finish at the end of the last activity, which is in 22 time periods. So if my due date is 23, what is my probability of meeting my due date? Which are probably a tighter way to represent is the probability that my random variable, which represents how long my project is going to take, is less than or equal to my due date. Because this is a random or stochastic process, the time it takes to do this project is not the same every time. It's random. So if that's true, what's the likelihood that I'm going to meet this? Well, the first thing we know is that we know that the average completion time is just the last activity. That's it's actually just summing all of the what you do is that you sum all of the averages on the critical path. So if I would take and add these up and these up and this one and these, if I sum those, I get an average of 22. Now there's a nice neat formula we can use in Excel called the SUMIF. And I'm going to look in this for zeros, and then the sum range is the corresponding vector of averages. I can also get my variance of completion time. It's the same thing, SUMIF. And I'm going to look here for zeros, and then the corresponding column that I'm going to add up are variances. We don't add standard deviations, but we can add variances. That's my variance. So my standard deviation of completion time is just the square root of that. So the probability of meeting a due date, the underlying distribution, if you look at all of these activities added together, the underlying distribution will be normal. So I'm going to use the norm dot dist. I put in the due date, I put in my mean, which is in cell F18. I put in my standard deviation, and then the last argument is always 1, and that's the likelihood, and I can show it as a percent if you want. The likelihood that I will finish in 23 time periods or less, given this project, is 73%. So what if I wanted to guarantee that I would be over 90%? Well, I would probably need to quote a time period of 25 to get this number high enough. Obviously, if I quote the middle, 22, then the likelihood of meeting that is 50%. So you don't want to plan around averages or you're going to fail half the time. Thanks.